So now the wedging itself. I really love wedging because so much of your job is going to be doing, figuring out different parameters, figuring out different flame lifespans versus input particles versus gas turbulences or whatever. And wedging allows us to just tackle whole piles of these things at once if we want. And we can just do it overnight and just choose the best one later on. So yeah, let's think about this first in terms of wedging, meaning we'll try multiple different sims of this seed here. And we talked about this a little bit. Currently, this is what we've been working with. If I change the seed, it will be a whole different thing. So I want to wedge that. Now wedging lives in the tops area. So let's go over to tasks, which is where tops are. Tops are task operators. It's part of Houdini's whole PDG, which is the procedural, I think, dependency graph. In any case, jump in here. We got this one node called the local scheduler. We'll talk about him in a minute. It doesn't actually hook up to any other node, so just leave it to the side. To do a wedge, we need a wedge. So drop down a wedge top there, and voila. I want to say, let's do 2 different values for that particle seed parameter we just talked about. Let's put a 2 here, wedge count 2. We need to name it something. I'm going to call it particle seed. Now you can call this anything. This is not actually hooking itself up to our particle sim yet, just because I'm calling it particle seed. But we are asking for 2 different values to be assigned to this. That way we can run a sim where this is set to the first value, and then we can run another sim where this is set to another value. Now the values that are assigned to it are going to be a function of how many wedges we want within, let's say, this range. So our range by default is 0 to 1. So 2 wedges from 0 to 1 are going to be 0 and 1. If I ask for 3 wedges, my wedges would be 0, 0.5, and 1, and so on. But I'm just going to do 2 for now. I just want to test this all for now. Like I don't want to do, I don't want to do all 72 frames, for example. Let's just set it down to 24 frames. We're going to need to generate our wedge values. We're going to need to run the actual caches of the sim. We're going to need to make renders of those. We're going to put text on them that says what the values those renders represent are. We're going to put them next to each other in another image so I can see them all at the same time, and then we're going to make it into a movie. All of those are different tasks that will be in order here in our tops world. But so, to make sure that they even work, I want to start with an easier set of parameters. So again, just 24 frames for now, just 2 wedges for now. We'll set it up to do more later. Now, what values should they be? Well, right now, we've been working on this with our particle seed being set to 2. So I'm going to say let's do 1 and 2. So basically, again, a range from 1 to 2, where we take 2 samples, which are just going to be that and that. To run these things, to execute these nodes, you need to tell them to execute. They're not just like, well, this is an arrangement of nodes and this is what they do. You need to tell these nodes to run. The way to do that is you can right-click it and go to Dirty and Cook this node. Really, just Cook Selected Node does it, but typically, if the node is already run, you need to dirty it first and then cook it, because it won't cook it if it's already successfully run. So really, dirty and cook this node is usually what you want. You can also just press Shift-V, which is what I'm going to do. So select the node, Shift-V. It ran it, 2 successfully completed jobs. That's what these dots are. These dots, on this node anyway, represents the 2 different wedges. Middle click on it to see what parameters they represent. So the one wedge had a particle seed of 2.0, and the first wedge had a particle seed of 1.0. Now, we might have many wedges of many different values, but they also have a unique identifier called wedge index. So no matter what the values are, the wedges in order will be wedge index 0, wedge index 1, 2, 3, and so on. So that we have basically set 2 different global variables. They're different colors because this is a float and this is an integer. We could make our particle seed be an integer. It doesn't really matter. More importantly, go to our pop network here, find the seed thing, and go particle, it's capital letters, particle seed. If we look at the value, it's 0. But this was 1, or rather this was 2, and this was 1. And I don't see a 1 or a 2 there. Well, that's because you have to actually click on one of them to set it. So now I'm looking at wedge 2, and now I'm looking at wedge 1. Like so. So now I can see it updating. And we can be reasonably assured that that's working. Now, it's not enough to just set values. I want to automatically run multiple caches. So I'm going to say, find our file cache down here. I can put, well, actually, let's just set it up first. So do a ROP fetch. I want to run that from here. So put a ROP fetch, which means go run that other thing. I'll move our export or final orange output thing down to that. This is not a ROP. A ROP is a render operator. This is a SOP, like everything else in here. Inside, however, is a ROP. ROP geometry output. So this is what we want to go here. So drag that there. There you go. And if I were to run this, it would run first the first wedge, and then the second wedge. The thing is, currently it's going to save them, no matter what wedge it's on. The same file, the same frames are going to overwrite each other. So we need to change our file path here to be in terms of the wedge index. Because again, this was the thing that uniquely identified each wedge, and we want our caches to be uniquely identified. So come in here, put to a W and a forward slash. Basically, we're making a subdirectory for our various wedges. Now right after our W, put 2 backticks. Backticks are the things that look like apostrophes, but what they mean in Houdini is I'm going to put an expression or some code, or in our case, that global variable particle seed, or wedge index actually in this case. We're going to put that in there, and it says to evaluate that. So put @wedge index, like so. And for the record, the forward ticks are usually the same key as the tilde, so go look for that. But so if I middle click this, you can see it says wedge 0 now, W0. And of course, if I click this, it would say W1. So now our caches, not only were they changing the input to the sim, they're now also changing where the output of the sim is being written to. And that's very important, or else we're just overwriting itself. Coming back to the ROP fetch top itself, we need to evaluate using a frame range, which is of course the frame range of our shot. And most importantly, all frames in one batch. Because many times with tops and things, let's say you're doing a procedural modeling job, let's say you had a sphere, and you're procedurally modeling, if you will, is going to be, I'm going to wedge different diameters of the sphere and then write them out. It doesn't matter what order you do them in. In fact, it's super efficient to just parallelize that whole thing, have different processors or even different computers on a render farm taking care of all those different ones. But when the order matters, which as you hold your mouse over here you'll see, this is used for simulations, you got to turn this on because we want them to run in order. So let's see what that does. Press Shift V on that, and we can see 2 different instances of Houdini have been spun up, and now it's simulating them. So each one of these, it's running both sims at the same time, and you can see what frame it's on based on what glowing thing here is. Now you do see 2 glowing dots. I'm not really 100% sure what that's about, but really it's just running 2 sims at the same time. And we can do that because right now this sim is pretty low res. It's only 24 frames, first of all, so it doesn't really get a chance to get to the larger state where it takes more voxels up. But it's also just low res in general. So we can do this. Later on, when we're throwing all of our RAM and CPU power at one sim, we won't be able to do that. But let's take advantage of this for now. I'll show you how to change it later. So we've done it. We can see the first wedge here corresponds to these 24 frames, and the other wedge corresponds to these 24 frames. So I'm going to go out here. Let's look at our cache node, and I'm going to move the tops thing to be over here. And there you go. We have a sim. And if I click this, we have a different sim. Isn't that cool? We can switch between them right here, just like that. Because we built up a little system to allow us to do that. This drives a global attribute, which drives our cache path. And then, of course, this is just displaying whatever's here. So that's pretty sweet. So that clearly works. And now let's talk about how to actually do the rest of the tasks we described.